Hi, welcome again back to my YouTube channel, and this video presentation with the aid of your host David or Dave will be centered on again something completely different. So in this video presentation I'll be talking about how you can test your 12 volt sealed rechargeable lead gel type of batteries for their actual capacity. I've already pre-tested this battery, and according to the label or the sticker that I've placed here, this battery has about 86% of its original nominal and actual primarily usable capacity preserved. So about 6.2 amp hours is still available for the appliance where this battery will be used, whether it is a uninterruptible power supply or UPS system or some alarm system, hobby, craftsmanship, and similar. Maybe a little more up close on the label. This is the manufacturer, EKO-Power. This is the model. Of course, 12 volts, 7.2 amp hours, and the rest of the information. You can probably also find the data sheet on the internet for this battery in particular. The plus and the minus terminal. This is where you would attach your Spade terminal crimp connectors. So nothing is dented or destroyed, deformed in any way, so the battery is very usable. Watching or browsing through YouTube to find out how other people test their sealed lead gel 12 volt type of batteries, maybe I wasn't looking diligently enough, but I didn't find anyone using this very practical and simple approach that I use for testing of my batteries. The tool that I use for this task or for my testings is this USB power meter, where these type of devices are usually or mainstream used for testing various power banks from different manufacturers of unknown capacities in order to confirm or debunk the previously mentioned. But this can also be used in this manner. So to test these type of UPS, for instance, used batteries. Of course, nothing can be done without a proper or a suitable allotted USB load tester. I actually don't use this one, but nevertheless I'll put the links to both of these in the description box below. I basically use these three type of, you could say, USB load testers. These were made custom using my rudimentary basic soldering skills, and I've attached these. They are basically light bulbs and different very older ones to these salvaged USB male connectors. And I've also made a sort of a custom cable to which I would attach the overall or the end USB power meter and the given load tester that I'm using. So this is this cable right here. I had to turn on the light in the room where I'm recording this video because outside from the morning on and lightning has been very poor. It's been cloudy for quite some time. Anyways, so now I'm just going to take out this USB power monitor from its transparent packaging, and we're going to look at the cardboard side. Most importantly, the information that is printed on it, the one in the front and one in the back. Now, before I dive straight in, I'm just going to mention one thing. When you usually order these electronic thingies off eBay, they come or they arrive packaged in a bubbly bag, so you don't get any information that come along with it. You just have to trust the description that was listed in the ad on eBay from the seller. So when I got this USB power monitor packaged in such a manner. I was really excited because I had all the information in one place. Now this is the front side of the cardboard label or packaging of the ROV. This signifies, of course, the model, KWS-V21. I think this first part, this is a short for the manufacturer, which is Keweisi with a W. And of course here you have some iconic representations on where you can use this USB power monitor to diagnose various symptoms in terms of voltage, amperage, and other parameters that you can measure with. So now we're going to look at the back side, which is much more interesting. Now this side is really much more interesting. Here, of course, you have a little description representation on what each parameter that is displayed on the LCD screen means. But what really caught my attention, my eye, the first time I saw this USB power monitor listed on eBay under, I don't know which seller was it, was the DC voltage measuring range. Because, you know, primarily when I came across these power monitors as such a couple of months ago, the videos that I saw on YouTube, people were using them to measure only the capacities of power banks. So they were used for the DC voltage range of USB, so 5 volts or 5.5 volts. But when I saw this one that it can go up to 20 volts, I immediately thought this would be a great tool to help me test these sealed lead gel 12 volt batteries that I have a bunch of laying around. And of course here you have also the DC current measuring range or the parameter of the ROV, so don't go beyond 3.3 amps or you will destroy your power monitor. Now before we move on with the video presentation, I'm just going to a little bit touch on the capacity measuring range or detection of the ROV. So the USB power monitor is supposedly to measure capacity up to a little less than 100 amp hours. So if I was to move the comma and get rid of this milli prefix, the power monitor could measure capacity almost to 100 amp hours. Now that's quite a large capacity, don't you think? So couldn't you use this device to test car batteries, for instance? You know, still 12 volt, but nevertheless. Interesting idea. Of course, you would have to test car batteries that are rated much less than this upper limit. So I don't know, 45, 60 amp hours, something like that. And then of course, in terms of the current load or the USB load tester, you would also have to use something at around at least a minimum of 2 amps or 2.5, even 3 amps in order to pull off the entire test. Because if you were to use a much lower load, you would probably run out of time here. So maybe that would be also an interesting way how to use this device. I don't know. Maybe someone on YouTube can try it out and make a video about it. Because I don't have a car battery laying around. But you know, if I'll get one and if no one will beat me to it, I'll make a video on that. Now we're just going to briefly have a look at the actual device. So, you know, this is how it looks like. Everything very compact. It also has a backlight, so you can also see it in the dark. Very handy. If you want to take this apart, the enclosure is basically made of a top and bottom part. And this is very neatly done. One side of the enclosure, let's say the upper one, has on one side 3 protruding plastic legs or pieces that are then attached through the bottom part of the enclosure or the latches of the ROV. So you basically have 3 locking mechanisms on one side and then also on the other. So if you want to take this apart without breaking anything, it's challenging because I have another one that went faulty. I'll probably make a video on that, why it went bad and what to look out for. When I tried to take it apart, I broke one of the protruding plastic legs. But you know, still very handy, very compact. So that's it. I'm going to show you my custom USB load testers. So let's start with this one. So, you know, this is basically just a general bulb that I found laying around. And this USB 2.0 A standard male connector, I found this. I think I desoldered this off I think it was either a broken USB thumb drive or something similar. Then, you know, I just made the connections using my soldering iron. Of course here, you know, polarity doesn't really matter, so it doesn't matter how you connect it up. So this is this one. Very handy. I think this one consumes at around 300 milliamps. So very low current load tester. So I'm just going to mention the parameters of this light bulb. So it's rated to operate at around 14 volts and consume at around 5 watts. It's a Starlux light bulb, so that is the manufacturer. Now my next custom USB load tester is this one. Also has another older light bulb attached to it or soldered onto it. I think this is a Elvolux light bulb rated to work at around 12 volts, and also the power consumption is the same as that light bulb over here, 5 watts. And this USB 2.0 A standard male connector, I think I salvaged this one from a USB 2.0 cable, I think. So this is this one I also use. Made the necessary connections using my soldering iron, a little bit of solder. So that's it. So this is this one. Now the last one is this load tester. So this is a much more stronger bulb. It is half the voltage, 6 volts, but it consumes at around 10 watts. So this is what I use for, let's say, 2 amp testings, when I want to test a battery using a 2 amp load. This is what I use, but I also seldomly use this bulb as well. And also, you know, this salvaged USB 2.0 connector, I think I also got it from a cable that went sour. Of course here I have a much more thicker copper wires soldered onto these connectors, so it can handle 2 amps. So that's it for my custom USB load testers. Before I go into the actual experiment, so yes, this video will contain a sort of experiment at the other half of this video presentation. I'm just going to show you this cable that I also made. So this is it. Here at the end you have these, I think they're called Spade connectors. These are the female ones. So Spade crimp wire connector. That is like the keywords that you would type in on eBay in order to get these. I'll probably leave a link or two in the description box for your pleasure. So this is this side, and then of course you have this USB 2.0 female plug with the enclosure, the top and the bottom. I'll also leave a link to these in the description box where you can get these on eBay. Now these wires, they're, I don't know, about 25 centimeters long. I don't know what is the gauge or number of these, but I know if I use my caliper and measure the diameter, of Of course, with the insulation on, it's about 2.5 millimeters. But you know, these wires are more than enough to handle, I'm just guessing here, currents up to, I don't know, maybe 10 amps, but 5 amps definitely. So I made all of this custom because I couldn't find these types of cables on eBay. I found the ones that had the alligator clips at the end and the USB 2.0 male connector, but not something like this, so I had to make this for myself. And of course, you know, the black wire signifies the minus polarity and the blue wire represents the plus polarity. I couldn't actually find a red wire that was of the same diameter as the black one, so I used this color classification. Maybe I could have made this cable shorter as well, but you know, the testing cable of course shouldn't be too long because that adds to the overall resistance. But you know, something very handy for you to do. So now we'll just connect everything up and I'll show you how I usually test these batteries. I have already connected the Spade connectors onto the end terminals of the battery. I also twisted the wires a little bit and I've already inserted the USB load tester, so I'll zoom in a little bit on this area and then we'll start playing using various load testers. So the load tester has nice backlight behind the LCD screen, so you can even see all the data in the dark, for instance. While this USB power monitor is perfect or very suitable for conducting these sort of tests, I think there is something that you should know and should be mentioned or brought forth. And that is that when you of course attach a suitable load tester onto the actual device, you shouldn't leave the experiment or the test as such unsupervised. Why is that? Well, when you don't know the capacity of the battery, so when you're doing the initial first observation detection test in determining what is the usable capacity of the battery, you should check on the experiment from time to time, because you don't want that voltage dropping below 10 volts. Some are even more precarious and they list 10.5 volts should be the lowest voltage on the battery when you would discharge it. So usually when I test these batteries, I make note of two data measured at two voltage references. One is at 10.5 volts and then the other is at 10 volts. So I make note of the measured or detected capacity at 10.5 volts and 10 volts. Then I usually repeat the test 2 more times. So then of course you have 3 measurements for 2 voltage references. Then of course you add all of the 3 numbers together and divide them by 3 so that you get a nice average. And when you do that, you also make note or you observe how much time has passed on the monitor, so that you know the next time that you're doing the second test, that you know approximately at which time the voltage on the battery will be going close to that 10.5 volt parameter. So now I'm probably going to start with this custom USB load tester and connect it onto the power tester or power monitor, and we'll observe the information displayed on the screen. So the bulb lights up nicely. I'll zoom in. So there you go. The discharge current is at around 0.33 amps or 330 milliamps. The capacity on the battery is starting to get measured, and also the clock has also started. So now we'll try the other load tester. So this one is a little less strenuous on the battery. It only uses up 300 milliamps or 0.3 amps. And now we're going to test this 2 amp load. Now this is really putting a lot of strain on the battery. 2.21 or 22 amps. And the light also shines very nicely. Let's zoom in on the screen. You can also smell a little bit of the solder, so I generally don't use this load tester. So now we'll try this one. Here, of course, you have a switch, whether you want to use the 1 amp or the 2 amp setting. But when you use this USB load tester on this battery, even the 1 amp setting is actually 2 amps. So we'll see. There you go. 2.3 amps at the 1 amp switch. So even this is really putting a lot of strain on the battery. And if I was to leave this unsupervised for a longer period of time, these resistors would really start to smell, and perhaps the board would come loose or be separated from that connector. So we'll try the 2 amp setting on the switch, and you'll see this will go to 4 amps. So I will quickly terminate the test at that point. So I flip the switch on the load tester. Good, this is going to be a very brief test because I don't want to destroy the power monitor. 4 amps. Now, even though these two load testers are ideal, or they might seem at a glance suitable to test the capacity of this battery because they have a discharge current well above 2 amps, they are in fact not that really great. Now, this custom USB load tester isn't suitable for testing this or these type of batteries, is because, well, previously when I connected it or inserted it into the slot of the USB power monitor, even though a couple of seconds passed, I could already start to smell the solder, so an unpleasant odor nevertheless. And if I was to leave the experiment unsupervised, I'm sure that already after, I don't know, 20 minutes, the bulb would become separated from these wires, or in essence, the entire circuit, this part would simply dissolve, and you would have solder, liquid, and then of course, solid all over the place, and a very unpleasant smell in your workshop or wherever you're doing this experiment. Now, this USB load tester or the other one also isn't suitable for testing these type of batteries as well. Even though, of course, this is a commercial product, so it is available freely from various suppliers or manufacturers on eBay, Amazon, AliExpress. So it's not something that is custom built per se. It still has its design flaws, and one of those, of course, the most critical one is the 2 amp setting, because when we tried it, The LCD screen on the USB power monitor indicated that it was drawing almost 5 amps, and that is well beyond the programmed DC current parameter measuring range, which is set or capped at the top at around 3.3 amps. So this was superseding it a lot. And if I was to leave this experiment unsupervised, in the worst case scenario, I would only destroy the USB power monitor in the process, not to mention something else might happen. So even if I was to leave the 1 amp setting enabled on this USB load tester through that switch, the problem would be pretty much the same as with my 2 amp custom load USB tester as well, and that is the emerging odor or smell of these 2 green resistors. So when I was priorly testing these, when I had it attached only for a couple of seconds into the USB power monitor, I could also, start to smell those resistors getting burned or something like that. I remember when I was determining or testing the capacity of another same type of battery, maybe 1 year ago or 8 months ago, when I connected this USB load tester into the same USB power monitor that you see in front of you, and I left the experiment unsupervised maybe for an hour or so. When I came back, the tester, or the load tester as such, was broken in half, and the 2 resistors were all over my workbench, and there was a very toxic odor in the entire room. And of course, the load tester as such was only consuming the same amount of amps as you have witnessed previously, only a little less than 2.5 amps, but the entire, you could say, printed circuitry board pretty much dissolved. So everything was separated, and also this USB connector as such, USB male one, and the entire board was broken in half, melted really. And there was a terrible odor in the entire room, so I had to vent the entire place. So definitely I wouldn't recommend using this load tester, especially unsupervised, if you want to test or determine the capacity of these batteries. I would suggest that you get yourself one of those USB load testers that have a heat sink mounted onto it, and there is a very small fan mounted on top of it, and it has, I think, a variable resistor or a potentiometer through which you can finally adjust or tune in the discharge current. I think that would be much more better option if you want to test these batteries in order to determine their actual capacity. So for the purpose of this type of experiments, avoid those commercial USB load testers. So the one here, avoid it. So I'm finally going to conclude or wrap up this video presentation on how else you can use this USB tester or power monitor to determine the capacity of your UPS or otherwise used sealed 12-volt rechargeable batteries. So as always, if you found the video interesting, leave the like button, checked. If you have any questions, comments, suggestions, ideas, leave them in the comment section below. Subscribe, share, and we'll see you soon. This is David, and have a great day or evening.